Hello and welcome to another video. In this video we're going to be continuing on with the system design problems. I'm going to be doing Design Ticketmaster today. Okay, so let's see. So this one, online platform. Yes, I'm a little bit familiar with like some ticket sales platforms. So we'll see how this goes. So you view events, search for events, book tickets. Okay, non-functional. Okay, so they have the users and stuff. So the way I'm picturing Ticketmaster, yeah, I guess I haven't seen the site in a while, is basically we can search for something and then we're going to get a bunch of events that match our search, just like most platforms, and then we can click on one event, we get a seat map, and then we can click on a seat and then buy the seat, something like that. So let's write the requirements for that. So non-functional here would be, so the main one I'm thinking, first you want to think about like consistency versus availability. So we actually want consistency for, and this is also where like it's not an all or nothing. The main thing we really want to have here is consistency for buying tickets. So we don't want to like have like if a ticket is gone, we don't want to let someone buy it again because that's going to be a problem. But everything else, we don't really care about consistency. Everything else is availability. Like if some event's updated or some event's added and we don't show it right away, we don't really care. Yeah. Okay, so we can say availability for everything else. And the other thing we probably want to have is, so typically for anything with a search, you want to have like a fast search. Fast search that lets you search for stuff quickly and convenient and so on. All right, so let's go for that. And then obviously this like high scale is like pretty standard for, so high traffic. I guess the other thing, kind of like for the LeetCode thing, we want to be able to handle surges. Handle surges for big events, right? So typically what happens is, and I do have some experience using this kind of app, let's say there's like a Super Bowl or whatever, anything like that. When that event comes up, a lot of people are going to want to buy the ticket. So there's going to be like a race, and then we have to figure out how to handle that. And yeah, I think I know, I don't think it was Ticketmaster, but I used something else, or like my brother used something else to actually buy tickets for like a Padres World Series or whatever thing. So I do know kind of how they handled that. So we can go with that kind of approach. So I'm a little bit familiar with that. Let's see how this goes. Okay, nice. Low latency search. Oh yeah, so I don't do this enough. So yeah, we'll just say low latency search. 200 ms is typically what you want to go for. I never give numbers. I should do that more. Okay, yeah. All right, core entities. So we're gonna have user who's like buying the tickets, and then we're gonna have, so we'll call these like things like events. So event is gonna be like Super Bowl, like a sport or like a performance or anything. We'll just call those events. So user event ticket. And then maybe we'll have like a venue or something, because like a venue can have, or a venue can be part of the event. I guess either one's fine. You can have a venue that like a venue can have multiple events, and an event can't have multiple venues, I guess. But some maybe something like, let's keep it simple. So user event ticket, something like that. That's good. You can have more, but this is like the core stuff. API. Okay, so now we're going to go through our requirements. So user should be able to view events. So let's start with that. So get events. So this is going to be like where you can search for events. So search is going to have some query params like match or something, or text, whatever, or, yeah, text. And then we want to have like pagination. Yeah, let's just say that this is for text, we get pagination and offset or something, right? So limit offset And just like for my other problems, this will return. So for the event, it'll return a list, right? So you don't need all the information for the event. You just need like a small amount, like the name, the venue, whatever. Something they can click in and get more. So this will be like the same thing as before, partial event. Then we can get the full event. So this is going to be like get events or event ID. This will return the full event. Then what else? So let's look. So we have the view, we have the search. Now we need to book tickets. So to book a ticket, it's gonna be like a post. Events. It's gonna be like this, right? Event ID. Yeah. So we're gonna buy a ticket, and maybe like here it'd be like tickets or something like that. So yeah, and this will make a ticket. So this will just return a 200, and the body will be what? User ID is going to be somewhere else. Probably going to have a seat, some kind of like seat information, seat info, and then time, whatever, and something like that. So the main thing is just like the seat info, right? Like whatever, where's the seat located? Yeah, something like that. So maybe it's also worth it to, yeah. So going back to the API schema, maybe it's worth that. Maybe it's worth it to have a seats. Looking back, because then like, yeah, like essentially whenever you create an event, you create a bunch of seats for that event, or yeah, and then the seats can be like bought or not bought or something like that, right? Okay, yeah, sure. I don't know. You can come up with like better stuff there, but something like this. Get feedback, and then I think that's it. Yeah. Okay. Cool. And yeah, you can see how like if you've been watching some of these, this is like really repetitive. It's all the same thing. Booking, current post, event tickets. I see. Your ticket should return. Oh yeah, I guess that's a good point. Yeah, that's a good point. Okay, so this should return actually not just like 200. This should return like the actual ticket with the info. Okay, cursor, whatever. Keep resource naming plural forms, event to events. Okay, yeah, events. Sure. Let's try this again. And then let's look at the sample answer here as well, just to see if we have any different stuff. Okay, let's take a look at the sample answer. Where do we see that sample answer? Get events. Okay, yeah, events. Yeah, it's fine. Booking, search keyword, blah, 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 and okay, so just a bunch of random stuff that you could search for. Cool. Post, ticket, payment details. Okay, yeah, payment details makes sense too. Okay. Yeah, so I guess, yeah, this could be like events. Okay, cool. All right. How will users be able to view events? Okay. All right, so we'll have client. This, so client doesn't need to be this big. We can zoom in. All right. So typical client, API gateway. Have the arrow is double-sided. Want that one? I don't know actually. This, whatever, we'll just do it this way. Okay, so client API gateway, and then we're gonna have two services. So we'll have the search service, and then we'll have the booking service. And we're not going to talk about the booking one here yet because this is just viewing an event. So, all right, we just do this. Pretend these are double-sided arrows. Then we'll have a, yeah, and the search, and so we'll have a DB here. And like this. So pretty simple. Okay, so let's talk about it, I guess. Okay, so the user is going to search, type in like a text, and then some other things like maybe start time, end time, things like that about the event. We'll send a GET request to the API gateway, which will have the GET events with all that stuff. We're going to call our search service. That's going to call our DB GET partial events. So it's just going to get a list of events back to the user. Then the user is going to see those, and then they can click on one of those events. And then if they click on one of those events, we'll make another GET call for the event with that ID, and then we'll have all that information with like the seat map, the event, all that kind of stuff. Yeah. Okay. One thing. Oh, right, data schema. Okay, yeah, sure. Forgot about that. Okay. So we'll have the user. We'll have an ID, some name, whatever, some stuff. Okay, that one doesn't matter too much. Then we're going to have the event, ID, performer, time, start, time end, blah, 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 more stuff. Okay, now we need to have a ticket. So this will be the ID. So I guess ticket, yeah, we'll say user ID, event ID, and then maybe like seat or something. And yeah, so every event needs to have this seat map that is either bought or not. So these tickets can be, I guess we'll have this separate. So we'll have a seats, and then these seats can be for an event. So every event will have a bunch of seats that that people can click on. So to get an event, we're going to get like all the available seats or something like that and then show them. Okay, so we'll add that as well. So seats, ID, like seat number or whatever it is, and then event ID. And then we'll have like a status. Okay, so let's redo this. Okay, so what's going to happen is the user is going to search for an event, or for not for an event, for a bunch of events. So they're going to have some text, some other stuff like end time, start time, performer, whatever, bunch of query params. We're going to call our search service. We're going to call our DB. We're going to get a list of partial events back, and then a user can get that list, click on an event, then that event will return the event plus, so the whole event information plus it'll take all the seats that are in the event, and the seats are going to have a status of like open or booked or whatever, and then we can show those seats as in like are they available or not. And then whenever a user gets a ticket later on, we'll mark these seats. So something like that. Okay. Maybe in the event you can have like a seat array or something as well. It's fine too. Missing connections. Yeah, I mean the missing connections is like, it's obvious how it's going to go. It's going to go here, and then it's going to call one of these and so on. This is just arrows. Let's take a look. Yeah, so whatever. Event, venue, performer. Okay, so they have performer as well. Makes sense. I mean, yeah, some small stuff there. Cool. Okay, so this has a tickets array, and we have a ticket table, so kind of similar. Yeah, I guess you could, maybe this is cleaner, so maybe let's change it to that actually, because that way the ticket will have a seat. And then, yeah, we could do that as well. So the tickets can be like bought or not bought or something. So we can change this so we can have a ticket array as well. And then the ticket will have a status of like bought, pending, something. And then that's what we could show for the seat. So it'll start out with all these tickets available. All right, it's fine. moving on. Okay, so I think I talked about this. So the way a user is going to be able to search for events is they're going to have a search feature where they can put in some text. They can also put in some options like performer name or just like whatever it is in the search that are going to be query params. The search is going to call our API gateway. It's going to call our search function. And then in the DB, it's going to get all the events that match that whatever like their, I guess we can match the name of the event. So each event will have a name. And then if whatever their search text, we're going to do like a full text search on the name and their search. And then the query params of like performer, time start, time end, all that kind of stuff for whatever they picked, the time interval and all that stuff. Okay. So yeah, I guess talking about that already. So. Okay. Missing connections, don't really care. Performer. Sure. I have that actually. Okay. Let's take a look. Search. Yeah, pretty straightforward stuff. So they have an event, we have a search. Okay, next. How will users be able to book specific seats? Each physical seat has one ticket to not consider. Okay, so let's first consider just like not consider surges. So let's just consider booking. So booking. So when you book something, you have access to it, and then you have to pay for it, and you can't have it forever, right? So when you click on a seat, you should be provided with like PayPal or Stripe or whatever to pay for that seat, and then if you pay for it, then that seat's yours. But you shouldn't have infinite amount of time, right? Like let's say I book a seat, I shouldn't be able to leave my computer on for like 2 days and then that seat's mine. So this is like a two-part process, I guess. We want to reserve the seat and then have the option to pay for it. But if we don't pay for it within a specific time, then we lose that seat. So I think what we can say is, so we can have another like third-party thing. And I'm not super familiar with like using a third-party payment system for things, but essentially we can have like Stripe here, and we can just say something like this basically, where they book, it calls Stripe, and I think you can give Stripe some URL to return to with like a bunch of other information. So essentially it'll happen like they'll book, it'll call Stripe, and then when they pay, the Stripe will like go back to the booking service. Now the main thing we have to figure out is like, how do we take a ticket, how do we give it to the user, and then make sure that like if they just like book a ticket and then just leave their computer on forever, how do we make sure that ticket is not available for them after some time? So yeah, something like that. So what we can do is we can have a ticket status, and then we can have a ticket like booked at field, like that might be fine, and then we can basically use that, right? So if the ticket was booked at some time, then when we get those tickets again, because it was booked too long ago, it's going to be available again for the next guy. So I think that's probably the easiest. So if it's not booked or booked at was too long ago, either one, fine. Or we can just have a last booked at, to be honest. Yeah, we can have a last booked at, and we can have status like bought or not bought, and then it's, okay. Let's go with that. So we're gonna add field last booked at, and even if two users, like let's say two users click on the ticket at the same time, like even if somehow they both get access to this Stripe thing, or to this, like they have the ability to buy it, because the status can only get updated once, like whoever buys it first will just get it, I think, and that's fine. So let's go something like this. Okay. So what we're gonna say is we're gonna have this booking service. It's gonna be attached to Stripe, and we have an API gateway, and then whenever you're on, so basically whenever you're on a seat, that seat will be associated with a ticket, and the ticket can have two things for a status. So it can either be bought or open or something. And if the ticket is open, then we're going to check when was it last booked. And if it was last booked over 10 minutes ago, then we're going to assume that seat is open again. So if that seat is open, then the user can click on it. We're going to change the last booked in the DB to whenever they did it. And then they're going to be redirected to Stripe. So they're going to enter a booking service, get redirected to Stripe, pay for the ticket. And if they pay for it successfully, then we're going to change the status to bought, and we're going to return them back that ticket. If they don't pay for the ticket, like let's just say they have their computer open, then this last book status will be too long ago, and then after a while, another user can go and that seat will be available. So we're basically just going to use this last booked at field on the ticket to determine if that ticket's available. So if this was greater than 10 minutes ago, then we can leave this to be available. And this can be some configurable number, like 10, 5, whatever. We can have like that in the code to determine that. Maybe for different events, we give different ticket like durations and so on and so on. We can make it more complicated, but this seems like the way to go. Okay. I think there's other ways to do this, but this seems like the easiest. Right track. Concurrent bookings. Content book the same seat. Okay. Two-phase booking with proper locking. Okay. Price field. Okay, yeah, that's fine. Okay, price. Seat table. Okay. I mean, it does. So, I don't think... Okay. So if we want, like, if we want row locking, how would we, like... I don't think we can prevent two users clicking on this at the same time. Like basically they would both call an endpoint to like to like have access to the ticket. And then one of those endpoint calls has to fail, essentially. That's what would have to happen. So if they both call this, it would have to fail. And okay. So what we could do is we can make this last, like this, we can lock the last booked at field. So when one person uses it, we can lock it. Okay. And then yeah, that should be fine. So let's say that. So what we could do here is if a user clicks on a ticket, they can be sent to the booking service. And then, so they're going to have this post request. And this post request is going to try to update this last booked at field. And this last booked at field will be locked in the database until another user is done with their request, essentially. So it won't be allowed to be updated. It won't be allowed to be updated until another user. Actually, yeah. So let's stop this. So I can see where this would be a problem. Like what if another user just it has to stay like locked forever, or it has to stay locked for like 10 minutes. So this kind of would be not the best. So maybe we could revise this. Like instead of a last booked field, we can have something else. So status bot open, that seems fine. Okay, so I think what we need to do is, yeah, okay, I think I got it. So, and this was in some other stuff. So we can have a distributed lock. So we can have like a Redis here. And so whenever someone whenever someone buys a ticket or like books the ticket, we can say this ticket is locked. So, and this ticket is locked. And we can give it a time to live. So in Redis, you can give time to live. So whenever someone tries this, we can say like, let's first check if this ticket is available. And if this ticket is available, then we are going to lock the ticket. And then if this ticket is locked, then we can't do anything and we'll return a failure. So what's going to happen is we're going to lock the ticket. We're going to give it time to live 10 minutes. And then someone else that tries to buy the ticket won't be able to because this will be locked. Now, the other main thing is we have to like show this in the seat map as well. So for like all of these tickets, we have to check like, well, is the seat locked or not? And then we have to like keep updating the UI ideally for these things. I guess we're not going to worry about like updating the UI for now. Like, yeah, because basically like let's say there's a bunch of people and I click on a ticket. I want to be able to update the UI somehow. How do I do that? I think what we can do is, yeah, we basically have to say like when this ticket is locked, we have to log in here somehow, and then we have to update the UI, and then the UI can just like refetch the event every so often. Actually, I think, okay, so I think I know what we can do. So we can say like this, because this is a distributed lock, both of these services can have access to it. So this can have access and this can have access. And then whenever we refetch the event, we'll just check like, okay, for all the seats, are those seats locked? We'll just check this is like the source of truth. So essentially we'll pass like all of our, or yeah, we'll check for all of our seats, like are they locked or not, and then that will give us like real-time updates. So we can just basically keep calling like get seat or something from here, just keep getting it every like 5 seconds. Okay, so let's go with this. Okay, so what we're gonna have instead is we're gonna have, wait, is it going? I think so. Let's see if it is. Weird. Maybe you might have to reload. Okay, so what we're going to do is we're actually going to have a distributed lock. And so someone's going to book a ticket. And when they go to the booking service, we're going to first check, is this ticket available? And if the ticket is available, then we're going to lock the ticket in Redis. And then we're going to go to the Stripe API and fill out all our stuff and then get it. Now, all these tickets will be locked for 10 minutes, so we can just give a time to live at like 10 minutes or 5 minutes or whatever. We can contribute per event. And then this is going to be like our source of truth, this Redis ticket lock. And then that way we can make sure we avoid double booking. Now, worst case, if we do have somehow 2 people go into this booking, if we didn't think of something, because we have atomic transactions, like we can only have this status updated to bot one time. So it's going to be like whoever buys it first will get it. But otherwise, if this is locked and we call book, and it's like concurrent, then we're just going to get like a 500 or not, yeah, I guess 500 or wherever we want here, saying this is the seat's no longer available. All right. Okay. Price, yeah, don't care about that. Connections, don't care about that. It's fine. Let's see how this goes. Okay, so the booking Stripe. Search that lock book. Okay, so they don't have a lock actually. The booking service uses a database with ACID, row level locking, optimistic concurrency control. When a ticket is being booked, database locks that ticket, preventing others from modifying until the transaction. Once the... Okay, I see. So if 2 users go to the booking, yeah. So we can't obviously have like row level locking as well, just like in the database. Like if 2 users go to booking immediately, yeah, okay, and they have a ticket status or something. Yeah, I don't know. Okay, whatever. Deep dives, 2-phase booking. Okay, so I basically have this already. Temporary hold and finalize product. Yeah. Okay, so we already have this with this Redis lock. So what's going to happen is the person's going to book. Someone's going to book, and then whenever they book, the Redis lock will lock that seat for 10 minutes. Then they're going to fill in their payment info, and then when they fill in their payment info, that status will be changed to a bot. And users won't be losing seats because that seat will be locked from other users to get, essentially. So only one user has access to it for 10 minutes. Yeah. And then the time limit will be the time to live on the Redis lock. Yeah, and from doing a decent amount of these, I think this is like pretty common. So Redis usually used for like cache or lock. And yeah, so whenever you need some like lock between a bunch of things, Redis is like a good one to use. Okay, nice. Detail, system handles payment failures. Yeah, so if there were payment failures, the seat would just stay locked. I mean, ideally, if there was a payment failure, if Stripe could communicate back here that like they failed, we would just unlock the seat. So that's how it would happen. Okay. Let's take a look. Okay, yeah, lock time. Two phase. Distribute. Okay, yeah, so user pull request. Okay, no user 10-minute window. Booked. Okay, yeah. Hold it for the user. Okay, sure. Okay. Okay, so 10 million concurrent users. So if there's 10 million concurrent users, yeah, I guess let's just figure out, do we need to do something here? Or do we need to do something? Essentially, this is like too many requests. I mean, I guess so. So I guess the simple thing to do usually for DB, like let's just say we do need to scale it. So we need to shard this on something, and we can shard it on the thing that makes the most sense, like event ID or something like that. So we can basically shard the DB on the event ID, and then we can have like read replicas as well. So that would be kind of like the main thing is just, yeah. Okay, so what we can do is if we have too many reads and the database can't handle the amount of queries, is we can obviously like vertically scale to make our database bigger, but if we need to horizontally scale, we can shard the database on the event ID. It makes a lot of sense. And then that way we can just make more instances of it. And then we can also have read replicas if this is a read heavy service. So, you know, there might be like one write replica and then like 10 read replicas or 5 read replicas or something for every write replica. So that way it's going to be like read heavy, and that'll be fine. Yeah, this one I'm definitely not the best at answering. Okay, well, database caching strategy. I see. Yes, I didn't think about that. Okay. Yeah, so let's talk about, I guess, common events, right? So yeah, we could try this again. So search, we can have like basically another Redis here. And this can just be a cache. And when they search for an event, so the thing we were going to want to cache for an event is like the event and the seat map. And then when someone searches for an event, we can just pull it up quickly because like all the event info, the whole event, like, yeah, all that stuff. We can get it. But honestly, I don't think that matters, because just getting an event, if it's just like one record in a table is not going to be slow. And yeah, we can chart the DB, right? So that kind of solves it. But let's see what they have actually. Okay, search service scale, application data on the application site, event cache. Okay. Reduce the load. Okay, yeah, I guess that makes sense. So I guess we can add Redis. The only thing I'm concerned about is like, how do we, if we use Redis, like if we use a Redis cache here, how do we keep the seats updated? So we'd basically have to have a kind of short time to live, but that'd be fine. So what we can do is we can have a Redis cache here, and then these events can have a very short time to live. So like, let's say there's like the Super Bowl. We can have a time to live of like a couple seconds, like 5 seconds or something. That's totally fine. So essentially what would happen, yeah, so let's talk about it. Okay, so let's try again. And then, yeah, this cache would go to the database and yeah. Okay, so let's switch to voice. Okay, so what we can do is we can do two things. We can first shard the DB on the event IDs to make more copies and have read replicas. The other thing we can do is also for our search event service, we can add a Redis cache. And then we could store really popular events there. So something like the Super Bowl, we can basically put into a cache, and then there would be a ton of requests because it would, everyone would be buying, like, that would be like all our traffic if that comes out. And then we want to make sure that like we're showing the seats kind of often, like the updated seats kind of often. So we can do this in one of two ways. I think the way I'm approaching is basically have kind of a short time to live on the Redis cache. So let's say 5 to 10 seconds. And then like, let's call it 10 seconds. And then that way we can have kind of an up-to-date seat map. So every 10 seconds, we would get the query again from the DB, and we would actually check like, what are all the seats that are being bought right now? That way we can kind of have like a pretty up-to-date map of the seats, which seats are bought, which seats are, we can probably just mark it as bought, right? We don't have to mark like in progress or bought. We can just mark it as bought or open. And yeah, so that way the seats are going to have at most a 10-second delay. But we're reducing a ton of database load. Okay, I think this is good. Yeah, so I didn't think about like how do we keep the seats kind of fresh. I think the way to do it is just have a cache, but then have a short time to live. Okay. All right. Horizontally scale. I mean, load balancers are like implied, so I don't. Okay. Yeah, I mean, so we'll have like a write DB and read replicas, I guess. So this is. Can I? Yeah. So basically, just have like a bunch of these guys. So. Yeah, I'm not gonna draw like load balancers and all that because that's like implied. So, all right, I'm gonna use search. Right, so search basically every time almost, or the easiest thing is just throw in Elasticsearch. So, Elasticsearch with a change data capture. That's basically like always the answer. All right, yeah. So like this. So, and then the things we want to index are going to be some things like event name, performer, maybe. Like if we can search for performer, things like that, like location, so on. So that's just basically how you do it. Okay. The other version is just like more indexing. So yeah, those are like the main two. All right. Okay, so what we can do here is we can add Elasticsearch for faster search. So this is the typical approach to full text search. So what we can do is we can have some inverted index on like the event name, the performer name, maybe stadium name, because those are going to be common things people search for. Like whatever you want to be searching for, you just add an inverted index on that. And then you add a change data capture, so that way when the database updates, the Elasticsearch updates as well. And that would make our search good. So this is like pretty much you can just like memorize, just know roughly how it works, and then just whenever you need search, just always add Elasticsearch. All right. Make a seat map, automatically refresh. Cool. This is what I was kind of getting at. Okay, so my schema already kind of handles that. So basically what we can do is whenever we're on the event map, we can just do like a poll every 5 to 10 seconds. Let's call it 5 seconds. And also our Redis cache of events can update every 5 seconds. So we're kind of polling at the same rate that the Redis cache of events is updating. And whenever we get the event from the cache, that will stay the same as it was before. But whenever we get the event again, we're going to get the event, we're going to get the seat map in our search, and then we're going to check the Redis ticket lock. And we're going to make sure that our seats are correct. The status can be based off of the Redis ticket lock, plus if the ticket was bought or open. So if the ticket was bought, it's never going to be available. But if it was open, we're just going to check, is it locked in the Redis ticket lock? And if it's locked in the Redis ticket lock, we'll mark it as bought on the diagram, the seat map. And that's like a product thing. We can have 3 statuses if we want to that we display, like red, white, and some temporary thing up to that. But basically, we're going to have like a 5-second poll is how we're going to handle that with a cache that has a time to live of 5 seconds. So we get fresh events pretty often. Right. And yeah, even a 5-second time to live, like if you think about it, we're having like thousands of queries per second or something, right? So we're saving like, we have to do 1 query and then skip 5,000, so it's still really good. Okay. Especially for like a big event. SSE, WebSockets. So generally WebSockets probably try to avoid. SSE makes sense, I guess. Thousands of users are polling. I don't think that matters too much because they're just going to poll the cache almost always. So, and yeah, I don't know. Let's see what they have. So server sent events. When a user views a seat map, server-side connection, the server then updates the client whether there's a change in seat availability, such as seats being reserved or booked. On the client will receive those and block off the seats. At scale, we'll be able to PubSub, dispatcher, Zeek. Okay, interesting. Yeah, but I think this is also reasonable. So how would you implement virtual waiting room? Okay, so this one I actually know a little bit. So basically what happens for these big events is they'll usually say like your number whatever, and then they'll let in X amount of people at a time. So they'll say like your number 10,000, and what would happen is they'll let in like 1,000 people at a time every couple minutes. So that's essentially kind of what we would have. And this is the problem. If you just let everyone in at the same time, basically what would happen is like let's say the Super Bowl, you let in 1 million people, they would click on a seat, and then the seats would still show fine, but they'd all be gone. So, it'll update and it'll show all seats unavailable. So we want to, so essentially the answer here is a queue. So we can just use like SQS. And we want to basically, we think we need like a FIFO queue. We might need multiple. So we could just use like SQS, and then what would happen is you would get every, you would say like this is where you are, and then basically people would have to wait, and you would just get a couple at a time. Okay, so let's talk about it. So what we could do is we can add like an SQS queue here, and then when a bunch of people are going to an event, we could put them all in a queue, and we can let in every X amount of people at a time. So maybe every 5 minutes we'll let in 1,000 people off of our queue. And that way we never get this like overload, and we can also actually let people who maybe get there early, or I don't know how we can handle that. Maybe it'll just be random, like the order in the queue, or maybe people like, let's say an event starts at 10 a.m. And someone gets here at like the day before and just has a site. No, that probably wouldn't be good. Probably random, I'd say. So right when the event is available, put everyone in a queue, and then get a little bit at a time. And if you can scale the queue, you can have multiple queues and things like that. So if you need multiple queues, maybe you'll get like 5 people off each queue or whatever. But just make sure that you maintain some kind of count of people that are currently in here. And then, yeah, I'd probably say the other thing is, if we let in every 5 minutes, we let in like 1,000 people. What if those 1,000 people never leave? So that would be kind of another good thing to do, is you could say once someone is on the site, give them like a timer and then kick them out after that timer. So that way we never have too much traffic. So essentially we have a queue, we have people come in, we have people able to do stuff, we limit the number, but then those people are on a timer where if they don't do something in 10-20 minutes, then they get kicked and then new people come in. And that way we can maintain short numbers of people. So I think SQS is fine here. First come, first serve. Yeah, well, kind of hard to say about first come, first serve. Like, because, yeah, if someone shows up 5 days before, is that first come, first serve? So, okay, let's take a look. Okay, so we have virtual waiting queue Redis. Interesting. We can use a message queue, but I'm going to order the Redis. When I use X page, are redirected to a waiting room, and their session IDs are added. Redis is great, highly efficient, large number of concurrent transactions every number of minutes. Pull from the front. I think Redis does have a FIFO queue as well. Yeah, I mean, SQS can have FIFO as well, so. Okay. Yeah, so I guess you can have Redis, but just some kind of queue here that's FIFO to make sure. You do want to make sure, like, once people are in here already. So, yeah, I think, yeah, you can have SQS, I think, can be FIFO or just random, and we can have SQS FIFO as well. So that would be fine. I think that seems pretty reasonable. Okay. Let's take a look at the solution. G2P, okay. Yeah, so API. Okay. I think we looked at most of these, so. Payment processor. Optimistic lock and distributed lock. Status. Yeah, so this also makes sense. Like, so you do something in database, and then periodically database can update. I think that's fine too. Plus its status with status and expiration time. Yeah, short transaction. Yeah, this makes sense too. Setting expiration time. Yeah, I think that's kind of what I was saying. So check reserved and expiration time. Yeah, I think this makes sense as well. That way only one user can do it. Yeah, so you can try to, yeah, so basically like 2 people can't, yeah, I think this makes sense. So in your transaction, you could, yeah, essentially if 2 people try it at the same time, it wouldn't work. Okay. And then distributed lock. Yeah, okay, makes sense. I think, yeah, I was kind of going this one. Maybe I didn't understand super well how you make sure you don't have concurrency, or you don't have, yeah, like race conditions, but I feel like it was fine. Okay. Caching, load balancing. Yeah, so I didn't do the caching, but caching makes sense. The main thing is with the caching to have the actual seat map be good. Virtual waiting queue, SSE. Yeah, I mean, usually in a queue, almost, once again, this is really common, any surge, use a queue. Like, there you go. And then, yeah, any search, use Elasticsearch or full text index. Like, this is, like, always the answer. So how can you reduce? Yeah. Query-based caching, edge caching. Okay, sure. Expected, mid-level. High-level design, probing the basics, API gateway. They may ask you what it does and how it works. Yeah, I think this is pretty common, where, like, if you're mid-level, they'll just assume you know nothing and then just, like, probe you like crazy. So anything you say, they'll be like, what's that? So I think that is good to, like be able to know what these things are. And then, yeah, once you're higher, I guess, They don't ask you because they assume you know it. Like they're not going to ask you like what's the type of an ID or something in a database, because that would be ridiculous. But maybe for like entry level or mid level, they might say like, okay, like what are the 2 different ways you can have an ID in a database, or some different ways. You know, do you just want to have an incrementing number or something like that? And some people might honestly say yeah. So okay, no double booking, cool. Okay, so gonna call it here. So hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.